Good morning, grade 10. We are still in the activity part of Module 1, weeks 1 to 4. And I actually have prepared an activity today. But before anything else, let us first unlock the problem that we actually have last meeting, simply because I have a technical issue also in my laptop. So on a while, I'll share it in the class. By the way, how is your learning resource material going on? Learning resource material, any update, Margie and Dimitri? Are you still with me? Can you hear me? Margie and Dimitri? Can you hear me? Okay. How is your learning resource material going? Huh? Oh, is it? Okay, hold on. Let me upload this in a while. Okay. Your exam is fast approaching. Okay. The schedule for your exam is 16, 17, 18. I think we will have it by 16 or 17. Okay. So you still have 1 week to prepare. And the deadline for your project, as a reminder, is next week, Friday, May 13th. 13, 1, 3. So hopefully you can submit. Okay, simply because it is 100 points. Okay, under performance tasks. Hold on. Let's have this in a while. Okay. Today is May 5. Okay, hold on. And after this, we will move forward to the example. Are you still with me? Hold on. I'm actually preparing the activity for today. And after which we will move forward to the problem that we opened or started last meeting. Right, there you go. Your activity number 2 is already up, problem solving. Okay. But again, as what I had promised, let's go back to the problem that we opened last meeting. Okay. Okay, for a while. Okay, hold on. That's what- Where do I submit? Okay, for physical output, Dimitri, you can submit it in the school. Okay, you can have it in my box. I have a box there. You can just put it there with your name, of course. Okay, for digital outputs, you upload it in your Google Drive and send the link to me. Make it public. Okay, we are now back to our problem last meeting, which has I also have a problem with my laptop. But it's okay. We can actually continue. So we already converted. Okay, we converted already the given. Okay, the question here is a balloon initially has a volume of 0.4 liters and a temperature of 20 degrees centigrade. What will be the volume of the balloon after it is heated at 250 degrees centigrade? So because this problem is talking about volume and temperature, it actually what applies to what law? What law again? So we need to analyze first what is being asked in the problem. What law talks about um, temperature and volume, or volume and temperature? What law again? Anybody from the class? Okay. Yes, we're actually talking about Charles' law. Thank you, Dimitri. Charles' law is talking about volume and temperature. So the formula for Charles' law is V1 over V or over T1, volume 1 over time 1 is equal to volume 2 over time 2, because they are what? They are directly proportional. So whatever happens to the initial will be happen to the next or the final. Okay, or whatever happened um to this volume will happen to the second volume. So that is actually directly proportional. So let's substitute. We already substituted. Okay. Let's make an annotate here. Wait. Okay. We already substituted. Okay. Sure. We cross multiply. Okay. As you can see, we cross multiply. Okay. The purpose of crossing it over in order for us to what? To isolate V2, because the question there is asking about what will be the volume of the balloon after it is heated to 250 degrees centigrade, meaning to say that it is actually talking about what will be the volume. So we are looking for volume 2, or the final volume. Okay, we're looking for this volume 2, right, or the final volume. So since volume 2 is actually the unknown, okay, we cross multiply. After crossing it over, okay, we actually have 0.4 liters times 523 Kelvin is equal to V2 times 293 Kelvin. Where did we get the 293 Kelvin? We converted what? We converted degrees centigrade, 20 degrees centigrade into degrees Kelvin. So as a result, we have 273 plus 20, 293. So we have 293 here, Kelvin. And for the 250 degrees centigrade, you just add 273. Okay, 250 plus 273, we have 523 degrees Kelvin. Okay, so substitute. Okay, now how can we isolate V2? Is to what? Is to divide it by themselves. Okay, dividing it by themselves will actually what? Cancel. Let me annotate. Yes, 293. 273 plus 20. Okay. Dimitri, are you still with us? 273 plus 20, it's 293. Okay. Where did we get the 273? This is constant. Okay, wherever you go, if you convert degrees Celsius to centigrade or degrees Celsius to Kelvin, you need to add 273 all over. Okay. 273 is equal to 0 degrees centigrade. All right. Let's move forward. Okay. We can now cancel. Okay. 293 here. Okay, leaving again the V2. Okay. And the other formula on the other side. Okay, we can now substitute for the V2. Okay, let's have this one. Okay, cancel Kelvin. Because again, we can actually cancel like terms. Okay, that is the ruling. We can now cancel Kelvin here. Okay, hold on. Okay, let's continue. V2 is equal to okay, 0.4 times 523. 0.4 plus 523 times 523 rather. 0.4 times 523. 209 over 2. 209.2. 209.2, okay, liters, of course. Because our unit used there is liters, we canceled. Okay, we canceled Kelvin over 293. Okay, V2 is equal to 209.2 divided by 293. 209.2 divided by 93, 293. We have point. Okay, 713. Okay, or because this is 7139, you can put it in this way, 714. Okay, liters. This is the final answer. Okay. Point 714 liters. Or you can actually say 0.71. You can put it in this way, 0.71 liters. Good morning, MD. MD is here. Okay. So going back, let's have a review. Again, the volume, a balloon initially has a volume of 0.4 liters and temperature of 20 degrees centigrade. So in the 20 degrees centigrade, we have in a 4 liters, we expose it in the 20 degrees centigrade initially. What will be the volume of the balloon after it is heated to 250? If you raise the temperature of the balloon to 250 degrees centigrade, what will happen to the volume? So that is actually the question. Okay. So because this is the problem is talking about volume and temperature, we are actually exposing ourselves. We are talking about Charles' law. Charles' law, in Charles' law, he actually stated that what? That the relationship between volume and temperature is directly proportional. Okay. It is not inversely. It is directly proportional. So whatever will happen to the volume will be happening also to the temperature. Whatever happened to temperature will also be happening to the volume. So let's take a look at this one. The formula, substitute the given, we have V1 or initial volume is 0.4 liters and T1 initial temperature rather is 20 degrees centigrade. We converted it into degrees Kelvin. Okay. V2 is the unknown because you're looking for the second or the final volume. Okay. And T2, or shall we say temperature final temperature is 250 because we heated up to 250 degrees centigrade. And we converted this also into degrees Kelvin. Okay. Substitute. The formula for Charles' law is V1 over T1 is equal to V2 over T2. Substitute. Okay, we have 0.4 liters over 223 Kelvin is equal to V2 over 523 degrees Kelvin. Since it has a known, we cannot directly proceed to calculation. We need to cross multiply in order for us to to isolate V2. Okay, the unknown. Crossing it over, meaning to say that what? We will be multiplying it with the opposite. Okay? So, as a result, we have 0.4 liters times 223 Kelvin is equal to V2 times 293 Kelvin. Okay, what we had done is we will be canceling what? 293 in order to isolate V2. Okay, because we'll be isolating V2, because V2 is the unknown there. So we need to divide it by themselves in order to cancel 293 on the other side. Okay? Divided by 293 and the other side is 293 to make it balance. Okay? Cancel 293 and there you go. We isolated V2. V2 is equal to 0.4 liters times 523 Kelvin over 293. This one. Okay? V2 is equal to, we need to cancel like terms. Okay? We can cancel actually the what? The unit used there because we're looking for the volume, correct? And this is temperature. So cancel 200, cancel K or Kelvin and multiply 0.4 times 523. We have 209.2 liters because we cancel the Kelvin over 293. And the result is 0.71 liters. So what will happen is the answer here is 0.71 liters. That's the correct answer. Okay? It's the correct answer. So if you heat or if we have an initial volume of 0.4 liters and heated with 220 degrees centigrade, if we're gonna increase the temperature to 280 degrees centigrade, it will rise up to 0.71 liters. How can we check our answer? Okay, go back to the formula. Okay, we need to go back to the formula and again, substitute. Okay, this is how to check your answers if it is actually correct. Okay, go back to the formula and substitute. V1 is 0.4 liters over T1, which is 293 Kelvin, is equal to V2, which is 0.71 liters over T2, which is 523 degrees Kelvin. So substitute. Okay. It should be equal to. Okay. We have 0.4. 0.4 divided by 293 is 0.001. 0.71 divided by 523, okay, is equal to 0.001. So our answer is correct. They are actually equal. So that's how to check if your answer is correct. Right? You need to substitute. Do you have any questions so far? Questions so far? All right. Let me share this to the class again. Okay, hold on. Okay. Your activity for today, since we still have time, is problem solving. This is activity number 2. We still need to hurry up simply because you're running out of time. Your exam is fast approaching. This is included in your exam. Okay. The question given here is analyze each problem and solve. Show your solution, write your answers in the space provided. Okay, I will be opening, okay, every question in order for you to upload. You can actually upload, require allow attachment. Okay. I'll be putting attachments here so that you can upload your solution if in case. Okay. I need solutions in order for me to check whether you understand the concept or you didn't at all. Okay. Again, in answering scientific questions, okay, you need to check what is being asked in that problem. Analyze what are the given in that particular problem, and then think about the concepts we already discussed. Okay, what are the concepts that we already discussed? You need to think it over. After which, you incorporate the lesson. Okay, you incorporate the what? The lesson itself. Or in that sense, we can actually have a correct answer. This is number 3, right? Okay. Let me finish this in a while. I'll give you a box in order for you to upload your answers or to upload your solutions. Okay, again, analyze each problem. Okay. And think about the concepts that we already discussed. Okay, there you go. All right. Again, your activity for today is activity number 2, problem solving. Please do it now because I'm opening it now. It will end this afternoon. I'll be checking your answers after because I'm now in the middle of recording your raw scores, right? And of course, your learning resource material, if you are done, please submit it. I will be in school tomorrow. Please submit it tomorrow in case. And the deadline is next week, Friday. So hopefully you can submit because that is 100 points, okay? Equivalent to 100 points and under your performance task, right? Do you have any questions so far? Questions so far? Grade 10? All right, I think that will be all for today, class. Thank you for participation. Let me record your attendance. Dimitri, MD, and Margie. Margie's late. Have a nice day, everyone. Take care. No, Meldon is late. MD. Have a nice day, everyone. Take care. Bye-bye. Enjoy the rest of the day.